All right, let's talk about exponential growth and how to model exponential growth problems. All right, so first of all, what is an exponential growth model? We've already talked about exponential growth functions, where functions kind of grow from left to right, and they get really big really fast. But if we want to use this in the real world, we have a general model. So anytime we say something grows exponentially, we can take and use this formula to find the function for its growth. All right. So in this formula, A is the initial amount, R is the growth rate, and it's written as a decimal. So if your percentage is like 12%, we would put in R as equal to 0.12. Okay, and T is the time in years. It's always in years. All right. So if you did, a year and a half, T would be 1.5, and so on. Okay. This 1 plus R here, this is called the growth factor. So if there's ever a problem that asks you for the growth factor, this is called the growth factor, that 1 plus R, that whole thing. Okay, and so let's do a problem real quick that uses exponential growth. This would be great to have in your notes if I was you. I would jot that down and put it in your notes. But let's look at an example. Okay, so in this example, I left the formula up here so we can kind of reference it. But the prize for a radio contest begins with a $100 gift card. So if you win the radio contest, they give you $100. Once a day, a name is announced. The person has 15 minutes to call in, or the prize increases by 2.5% the next day. So if no one gets it the first day, it increases by 2.5% the next day. So that'd be another $2.50. So it would be $102.50. All right. So we wanted to write an equation that represents the amount of the amount of the gift card in dollars after T days with no winners. Okay, so let's kind of break down what's going on here. The initial amount, what you're starting with, is $100. Right, so A is equal to 100. So I'm going to write that down. A is equal to 100. Actually, that's a really bad A. A is equal to 100. All right. The rate is 2.5%, but remember, we would never write 2.5. We want our percentage as a decimal. So our rate, R, is equal to 0.025. And if you can't remember how to do that, just divide it by 100, and that will give you the rate R. And then let's see, and after T days. So if I'm kind of checking off things in my formula, I've got A, that's great. I've got R, that's good. And then Y, I just want to usually leave that as Y. And T, I want to leave as T, because this is going to be a function that we could plug in T and figure out what Y is. So my equation then is just Y equals 100 times 1 plus 0.025 raised to the T. All right, or you could just write this, Y equals 100 times 1.025 raised to the T. And we would never do 100 times 1.025 and then raise it to the T. We have to write it as 100 times 1.025 raised to the T. All right, and so that's our growth model. And what this does is if I plug in a T, like 6 days, that will tell me how much the prize is going to be worth after 6 days. So in this next example, how much will the gift card be worth if no one wins after 10 days? That's just what is Y when T equals 10, when there's 10 days. All right, so if we plug this in, we're just going to go Y equals 100 times 1.025 to the 10. Right, now I know what T is. It's to the 10th power. And if you plug that into your calculator, I believe you get $128.0. So if no one wins this thing after 10 days, that prize is going to be worth $128 to the next person that calls in. All right, and that's it. So you're just looking at plugging in your initial amount and your rate, and that gives you the model, we call it. And then we can use that model to either look at how much the prize is going to be worth after a certain number of days, or we could also take how much we're going to win. Say we want to know how many days it's going to take to win $150, and then solve it for T also. And that's it for exponential growth.